Exercise 3.7, find the sum from r equals 1 to n of 2 divided by r plus 2 times r plus 4. So it looks like another partial fractions kind of thing that we can do. So let's go ahead and use our partial fractions decomposition theorem. 2 divided by r plus 2 times r plus 4 is equal to a divided by r plus 2 plus b divided by r plus 4 if and only if 2 is equal to a times r plus 4 plus b times r plus 2, and then taking r equals -2 gives us that 2 is equal to 2 times a. So that means that a is equal to 1. And also taking r equals -4, we get that 2 is equal to -2b. So that means that b is equal to -1. And so this thing is actually equal to the sum from r equals 1 to n of 1 divided by r plus 2 minus 1 divided by r plus 4. Now the next question is, what do we do here? Because it doesn't look like we have some function that we can use the method of differences, obviously. But then we stare at it for a little while and we say, well, okay, actually, the only thing that's missing in between the r plus 2 and the r plus 4 is an r plus 3. So we can actually write this as the sum from r equals 1. See if I can fix that equal sign. R equals 1 to n of 1 divided by r plus 2. And then we can add 1 divided by r plus 3 in the middle. But then we better subtract it again. So minus 1 divided by r plus 3, and then minus 1 divided by r plus 4. And then we can go ahead and use the distributive property of our sum here. So we can actually write that as the sum from r equals 1 to n, and it actually doesn't matter which order we add these things in. So I can go 1 divided by r plus 2 minus 1 divided by r plus 3, and then plus the sum from r equals 1 to n of 1 divided by r plus 3 minus 1 divided by r plus 4. And now we can use the method of differences on them separately. And clearly for this first one here, we can take our function f of r is just equal to 1 divided by r plus 2. And then so this one here is going to be f of 1 minus f of n plus 1. And so that's just going to be 1 over 3 minus 1 divided by n plus 3. Okay, and then plus. And now we just do the same thing for our other one. So clearly for this one here, our function is going to be f of r is equal to 1 divided by r plus 3. And so this sum here is going to be f of 1, so 1 divided by 4, and then minus 1 divided by n plus 4. And then from there, we just simplify at least a little bit. So a third plus a quarter, so that would be 4 over 12 plus 3 over 12, so 7 over 12, and then minus 1 over n plus 3 minus 1 over n plus 4. And that's all the simplification I'm willing to do for that one.